All right, so let's go. Let's just go ahead and go into it, just so we can, a little bit faster. But you guys, have you guys done the homework?
The slides.
Yeah. The slides.
I did the slides.
I just gotta turn it in.
Okay. Has it been? Was it okay? Not too hard.
It was hard.
It was
Ish.
kind of hard.
Was it?
It was okay.
Like hard, but not hard at the same time. Shut up.
Okay. That's fine. So, well, for today, we're just gonna expand on that a little bit. I mean, we still have our regular two-step equations, but we're gonna expand a little bit more on, when we have equations that are maybe a little bit not tougher, but I guess just require more steps, right? So we're getting more into like multi-step equations. Yeah. So let's start. Let me just share the screen. Let's start by saying, okay. It's a situation where we have all this separated by an equal sign. Okay. So in this situation, I guess what's different about these equations from the previous ones?
It's longer.
It's bigger.
No
little bit longer.
parentheses.
Well, there's no parentheses, yeah. It is a little bit longer though, right? And so before really we can do anything, oh, and another thing that I forgot to mention is that now we have variables on both sides, right?
Yes.
So when we have variables on both sides, what's our goal? What do we want? What do we want to make sure that we have before we can solve it?
Find out what x is.
Well, we want to find out what x is, yeah, but we have variables on, if we have variables on both sides and then numbers on both sides, what do we want? What's our ultimate goal before we can actually solve this equation?
Don't you have common denominators?
So let's see, not common denominators, but I know, I think I know what you're getting at. You say you want to combine like terms, right? So,
Yes. Combine them.
so yeah, let's go ahead and just pay attention to that first, right? So let's say we're going to focus on this side, and let me actually. We want to focus on one side of the equation at a time, right?
Okay.
So looking at this, 9x plus 4. Do you think there's anything that we need to do to that?
Try to get rid of the
no.
x.
You can't do anything there, can you?
Not really, right? I mean, we have 9x, which is a variable, and we have 4, which is a constant, so a number. So, that's about as far as we can go on that side. So let's just go ahead and move it over and think about this side. Okay? Is there something that we can do here?
You can combine negative 5x to 13x.
Exactly. So if we combine our like terms, then we would simplify one side of the equation. So negative 5 plus 13x, what does that give us? So it'd be negative 5 plus 13.
18.
Negative
X.
5 plus
Negative 18.
7, 8, 9,
Actually,
5.
remember,
Wouldn't it be negative 7x? Wouldn't it be negative 7x?
Why?
Not
7 plus 5 doesn't equal 13.
You subtract.
It's 8x.
It would be 8, actually, yeah.
Yeah, 8, my bad.
Okay, so 13x or negative 5 plus 13, right? Remember, they're different signs, so we have to find the difference, and then it's going to stay positive, right? Because 13 is a bigger number. So 8x plus 14. Okay? So now that we have that, let's just say, all right. Okay, so now that we have that,
13x.
we have 9x plus 4 on the other side, right? So now that both sides are simplified, now we can start solving our equation. But, you know, going back to my original question, right? What's our goal here? What do we want?
Solve for x.
We want to solve for
Solve
x.
for x.
But more specifically, we want to make sure that variables are on one side and numbers are on the other side, right?
Yeah.
Yes.
That's what's different here. We have variables on both sides. We need to make sure that we only have variables on one side and that we have numbers on the other side, okay? So with that in mind, how are we going to start this? What are we going to do first?
When you do like subtract 4,
Okay, so we can subtract 4, sure. We can do that first. So what's going to happen here is that we're going to cancel that out. 9x goes down. And now we have 8x goes down as well. And then we have 14 minus 4. What would that be?
10.
10.
Okay. Okay. So then what's the next step? What do we want to do after this?
8x minus 9x.
So actually 9 is the one that is by itself, right? So to keep it by itself, we need to move 8x, okay? So how would we move 8 to the other side? So our 8, what would we?
Minus 8x, right? On both sides.
don't you like subtract 8 or would you add it?
We'd subtract it because it's positive, so we'd subtract it, right? So that means that we're going to subtract 8x on both sides. And so what are we left with? 9x minus 8x?
1x.
1x
1x
equals
plus 10.
10. So, I mean, this is pretty much solved, right? But let's just say we want to get rid of that 1.
It'll be x equals 10, right?
Right. So if we wanted to get rid of that 1, though, what would we do?
We just over 1.
We divide by 1, right? So that just cancels out, and x is equal to 10 divided by 1, which is still 10, right? So in other words, once we're down to 1x, then that's our answer, right? So again, our goal is to make sure that variables are on one side and numbers are on the other side, okay? So try another one. Let's say we had 9x minus 7. We had 7x minus 11. Okay. Now again, let's focus on each side. Is there anything that we need to do? For example, on this side, 7x
No.
minus 11. Is there anything to do?
No.
What about this side?
No.
Nothing.
Nothing, right? Okay, so since we're good, then we can start solving this equation, okay? So what do we want to do first?
Plus 7.
Plus 7, okay, we can do that. So we can add 7 on both sides. That means that we are going to cancel that out. 9x goes down, 7x goes down. And then what's negative 11 plus 7?
Negative 4.
Negative 4, that's right. Okay, so then what's our next step?
Subtract 7.
We're
X.
going to subtract 7, yes. And why do we subtract the 7 instead of the 9?
Because you're trying to get them all, the x on one side and the whole number on the other side.
Exactly. So since we're going to subtract 7, then we're going to have 9x minus 7x, which is
2x.
2x. And then on this side, we have -4. Now we're at our last step. And now we say, what's almost always our last step?
You divide.
Divide.
Divide both sides by 2. So x is equal to -4 divided by 2.
It would be -2, right?
Yes, -2. All right. Let's do next example, let's say. (17) plus 4h plus 2 is equal to 1 minus 5h. Okay, so again, focusing on this side, what do we need to do on this side?
Combine 17 and 2.
17 and 2. We're going to combine 17 and 2, right? We want to simplify it. So 17 plus 2 would give us 19. Is there anything else?
No.
All right. So now we can move on to the next one. What about in this side? 1 minus 5h. Is there anything we need to do there?
No.
All right. So we can just write this down. All right. So now let's start solving this equation. So what can we do first?
You can subtract 19.
Yeah, we can subtract 19. And remember, don't be confused by trying to subtract it to the variable, right? We would do this, and now we have 4h and -5h. So what's 1 minus 19?
18.
And it's -18, right?
Yeah.
Okay, so what's next? What else? What can we move next?
Do -5 to each side.
So
I mean, +5.
we would actually add, right? Because the 5 is negative, so we would actually add 5h.
Yeah.
So we're going to add 5h on both sides. Okay. So then 4h plus 5h would give us
9h.
9h, and then we have -18. What's our last step there?
Divide.
We're going to divide both sides by 9. So that
Should
cancels
be
out. H should be equal to
2.
-2.
-2, yeah.
Okay. Good so far?
Yeah.
Yeah.
Okay. Now let's say that we have this example.
Is that a K?
Yeah, that's K. All right. So focusing on each side again. What do we first need to do right there?
You distribute, right?
Right, we're going to distribute. That means we're going to multiply into everything inside of it. So 8 times 10, that gives us
80.
80.
80.
And then 8 times negative k, that's
Give it
negative
8K.
8K. Yeah, negative 8K.
Yeah. All right, let's now move the other side. So then we have this situation. We also need to distribute. So what's 2 times k?
2K.
And then 2 times 1?
2.
2. Okay. So is there anything else we need to do?
In the bottom.
I don't know.
Nothing else, right? So
No.
we can go ahead and start solving. So what can we do first?
Two minus 2 to 80.
Okay, we can move that 2. Sorry, minus 2 you said, right?
Yeah, on the
So minus 2. So that cancels out right here. And then 80 minus 2, that is 78. And
78.
We're going to bring everything down. Negative 8k is equal to 2k. Okay? So now this is a little different, right? Because now we started with the other side. And the order doesn't really matter, right? In the end, as long as you keep everything consistent, then it should be no problem. So in this situation, now we're actually going to do, what are we going to do next?
Plus 8K.
Right, so this time we're going to move the variable from the left to the right. We've been, in the previous examples, we did it from right to left. But now we're going to do it the opposite, which again doesn't really matter, right? So if we cancel this out, make sure that 78 is there. So then we have 2k plus 8k,
10K.
which would be 10k. Yes.
Yeah.
All right. So what's our last step? What's almost always our last step?
Divide.
like
Divide. So 78. So we're
Wouldn't
gonna
it be
divide.
7.8?
So k would be equal to, and I mean, I'd prefer to just leave it as a fraction. If it's going to be a decimal, I prefer to leave it as a fraction, right? And we can actually reduce this. So if we divide both of these by 2, that means that we can actually reduce this to 39/5. And again, to me, I just want to avoid working with decimals whenever possible, okay? So you're not wrong if you put the answer as a decimal, but I'd rather see it as a fraction, right?
Yeah.
Decimals start becoming kind of difficult when there's too many of them. Okay. So just a couple of things based on hidden math, okay? So again, things that really aren't there, but we don't see, but they're actually there, right? So for example, let's just think of a variable, right? X. So what do we assume is in front of an X whenever there's nothing there?
A 1.
A 1.
1.
Right? Remember, our goal when we're solving equations is that we want to end up with 1x, okay? So a lot of people get confused because when they don't see anything there, they think it's a 0, right? Well, no, if there was a 0, that means that we wouldn't have anything, right? That means that 0 times x would just be 0, okay? So yes, we assume that in front of every variable, there is a 1. Same thing if, let's say, we had a negative y. What do we assume is there?
a negative 1.
Positive.
It would be a negative 1y,
Oh.
right? So even though nothing's there, we still assume that that's a -1. And now, let's say, for example, let's say I had -y equals 10. Would that, let's say I have something like this, would that be the correct answer?
No,
No, why is that?
because -y is still 1y.
Right, so we need to get rid of that negative, okay? We need to make it a positive. So in this situation, we would have to divide both sides by -1, right? Because remember, in front of that y, there is a 1.
Yeah.
So we want to make sure that that cancels out, turns positive. So we have 1y, and that would become -10.
-10, yeah.
So that's why it becomes important, right? You need to make sure that, you know, if you still have a negative, you know that that's not the solution. Okay. And finally, we have something in parentheses. Let's say we have x plus 4. If there's nothing on the outside, what can we assume is there too?
A 1 in front of the x.
So 1 is still there, right? Because if we were to distribute a 1, it'd still be the same thing, x plus 4, right?
Yes.
But now let's just say we have a negative on the outside.
-1.
That's a -1, right? And this becomes important because then if we distribute, then it changes everything inside.
Yeah.
So -1 times x, that turns it into -x. And -1 times 4 is -4. Okay. All right.
Yes, sir.
Okay. So just a couple things to, you know, be aware of. All right. So I think we ended up losing Lejean, but okay. I know there was a couple that weren't going to be able to make it today. But either way, you know, the video is going to be up there, and we'll have again homework on Google Slides. So make
We're
sure.
gonna do Google Slides again.
Yeah. So make sure that, you know, you're showing your work so you can get the full credit. And if you're having any problems, message me on Remind or whatever you need, so I can help you out with it. Now, again, you guys are doing a pretty good job with the homework. You're keeping up, so that's good. But just make sure that if you have everything turned in by Friday. Now, I'm going to